Welcome. Let's try to solve another Leetcode problem. 366. Find leaves of binary tree. So for this problem, we are given the root of a binary tree, and we need to collect tree's nodes as if you were doing this. So collect all the leaf nodes, remove all the leaf nodes, and repeat until the tree is empty. So this just means we're gonna just check the leaf nodes layer by layer. So this is gonna be the first layer, second layer, and third layer, and then we're gonna just return the final result. Yeah. So the final result is gonna be layer by layer. So for example, the first layer is gonna be 4, 5, 3, and then 2, and then 1. So how can we solve this problem easily? We can use post-order traversal. So for example, how are we gonna calculate the depth of the tree? Yeah, it's the depth of the tree. So for example, from here, it is 3. So from here, it is 2. So here is 1, definitely. Yeah. So we're gonna define the depth of the tree from the bottom to the top. So for here, the depth is 1, 1, 1. So this is also 1. And this one we're gonna set it to 2, and this one we're gonna set it to 3. And we're gonna use this depth value. So if it is 1, we're gonna put it inside the dictionary, and we're gonna put the node 453 inside the dictionary with a depth value of 1. So we're gonna put 453. Yeah, and this is our dictionary. And now for the depth of 2, we're gonna put a node of 2, and for the depth of 3, it's gonna be our final node. So yeah, we're gonna put a value of 3, a value of 1. And finally, we just need to return d dot values, because this is a dictionary d, and the d dot values is going to be all those arrays. Yeah. So let's first define a DFS function, and inside it's going to be a node. And let me define a dictionary. It's going to be a default dict. Inside it's going to be list, and then I'm going to run the DFS, and finally I'm going to return list d dot values. Now for the DFS, I'm gonna check the node. So if not node, I'm gonna return a 0, because currently if it is empty, so the depth I'm gonna set it as 0. Now I'm gonna check the left and the right side. So I'm gonna run the DFS, because this is a post-order traversal. If I were to know the depth of this node, definitely I would to know the left and the right first, and then I would to know this node. So for example, this node 2, I would to know the depth of the left, it is 4, depth of the right, it is 5, so the depth is 1. So 1 plus 1 is going to be 2 for this node. Yeah. So here going to be node dot left, and here going to be node dot right. Yeah. So the depth is going to be a maximum of the left and the right plus 1. And for the dictionary, I'm going to use this depth, and I want to append the node dot value, and finally I'm going to return the depth. Yeah. Now let me just run it to check if it works. Yeah. So this is a post-order traversal. So before we are calculating this depth, we already know this L and R. It means the depth of the left subtree and the depth of the right subtree, and then we're going to use it to put all the values inside of the dictionary. And finally, we're going to list the values of the dictionary. Yeah, let's just wait and see if it works. Yeah. Now let me just submit it to check if it can pass. Now as you can see, it passed for all testing cases, and it's pretty fast. Thank you for watching. See you next time.